In this video, we will be looking at question number 10 from the 3.3 homework. A rectangle is inscribed with its base on the x-axis and its upper corners on the parabola y equals 6 minus x squared. What are the dimensions of such a rectangle with the greatest possible area? Let's start by looking at a picture of what this all means. So if we're looking at our axes, it tells us that the base is going to be on the x-axis, so I don't need to go any lower than that, and then I have this parabola. Pretend like the top of the parabola actually happens on the axis where it's supposed to. When it says the rectangle is inscribed, all it means is our top corners are hitting the parabola, and then it wanted us to use the x-axis as our base. Keep in mind that the formula for this parabola is y equals 6 minus x squared. If we rewrite that, that's negative x squared plus 6. So this is a regular old x squared parabola with a vertical reflection and moved up 6. So this top point is at 0, 6. So we know it's at least going to be shorter than that. Now we're trying to maximize the area of this rectangle. Area is equal to length times width. So I somehow need to figure out what's going on here. I'm going to pick some point here. I'm not sure how far over I've gone. Let's just say I've gone over x. Well, I'm still on the x-axis, so the y value is 0. If I go up until I hit the parabola, this point is going to be at x, comma, 6 minus x squared. Because to find the y value of that point, you plug the x value into the formula. So I just plug in x and I get 6 minus x squared. So that gives me that. What about how wide this thing is? This is going to be symmetric over the y-axis, assuming I know how to draw. So this point would be negative x comma 0. So the whole length of this thing is x plus x, which is 2x. The width, or in this case the height, is how high we go above the x-axis, which is the 6 minus x squared. If I distribute through the parentheses, I'm looking at 12x minus 2x cubed. And that's what we're trying to maximize. Now, in this case, we don't have a formula for how to maximize that. So we're going to have to use our graphing calculators. So we're going to go to our y equals, and we're going to plug in 12x minus 2x to the third power, and hit graph. All right, well, in this case, our x value is positive. So we want the positive x value. Oh, it looks like it's a little bit off my graph, but it should still be able to figure it out. So I'm going to go second trace, and that'll bring me to my calculate menu. I want to find the maximum, so I'll go 4. I know that this maximum occurs somewhere between, say, 0 and 6. So I'll use a left bound of 0, enter, a right bound of 6, enter, and as a guess, I'll just press enter again. Hopefully it'll figure it out. It's telling me that at this maximum, x is equal to 1.4142153. So remember that x is the distance from our origin to that point. It's asking for the width and the height of my rectangle. Well, the width was x and x, so 2x. So I need to multiply my x by 2. So if I take 1.4142153 times 2, I get that my width is equal to 2.8284 about, and my height was 6 minus whatever x is, 1.4, oops, 4142153 squared. 3.999, okay, that's 4. So we'll have a height of 4.